There are three main types of luminescence. Phosphorescence, which can be found in glow-in-the-dark paint. This type of luminescence is created after a radiation source stops giving its energy. The second type is fluorescence, which can be found in fluorescent light bulbs. This light is produced when radiation is being put into that source. When you turn a light bulb on, it gives the source. When you turn it off, it stops. And finally, there's chemiluminescence, which is light produced through a chemical reaction. And that is going to be the one we are talking about today through the reaction of nitrous oxide and carbon disulfide. But before we get into the whole entire experiment, there are four main chemicals that we will be using in this experiment. The first one being sodium nitrate, hydroxyl ammonium chloride, nitrous oxide, and carbon disulfide. Now, there are many reasons why we should be using our safety goggles and aprons, and that's because if we look at carbon disulfide, for example, it is very flammable, it is an eye irritant, skin irritant, and it's also toxic. The way you want to dispose of this is essentially you put it into a container and send it off to a waste lab. Nitrous oxide is also highly flammable, it's an oxidizer, it's very toxic, and it can produce narcotic effects. The way that you would go about disposing this is you would put it in a fume hood anytime you work with it and let it evaporate in there. Hydroxyl ammonium chloride is a very nasty substance. It is very toxic, corrosive to the human body as well as other metals. It is an eye irritant. It's also carcinogenic and very skin sensitive. The proper waste disposal for this should be put into a container and also sent to a waste collection point. Last but not least, we have sodium nitrate, which is an oxidizing solid, has an acute toxicity from oral, dermal, and inhalation. And it's also an eye irritant. The proper waste disposal, it should be contained and sent somewhere for it to be disposed of. And before I get into the whole entire procedure, I would like to show you a few examples that I found on YouTube of the barking dog experiment. You might have noticed if you listened really closely to the two sounds projected from each one of the experiments, and one was a very large tube and one was a medium-sized tube. So essentially, when a larger tube is present and the explosion occurs, it produces a longer sound wave, so it's a longer frequency, creating a lower tone compared to that in a smaller tube that has a very smaller volume and area that creates a smaller wave frequency, creating a higher pitch tone. First step in creating the barking dog experiment is we need to get nitrous oxide. Of course, you can go and buy it yourself, but that takes the fun out of the whole chemistry aspect. So we will be creating it today. There are two ways to make it. There's an industrial way, which is shown here. The industrial method uses ammonium nitrate to produce nitrous oxide and water. This can, however, be very dangerous.
The
safer method, shown here. The safer method uses sodium nitrite and hydroxyl ammonium chloride to produce nitrous oxide, sodium chloride, and water. To prepare our nitrous oxide, we are going to start by creating two aqueous solutions of hydroxyl ammonium chloride and sodium nitrate. We're going to be using water to dissolve both of these at same gram amounts and same milliliter amounts. The dissolution of both hydroxyl ammonium chloride and sodium nitrate is very endothermic, so the solution will cool down over time, causing the solution not to dissolve as readily. So we are going to be preparing it with a hot plate just to speed that process up. The hydroxyl ammonium solution will then be added first into a 3-necked flask, as I will show here. Then on the middle there is an addition funnel, and that will be filled with the sodium nitrate solution. It is key to know that you want to be adding this sodium nitrate to the hydroxyl ammonium chloride solution to prevent any excess buildup of pressure and gases. This reaction also produces a lot of heat, so we will want to use an ice bath underneath the 3-necked flask to require or to keep water vapor from moving into the nitrous oxide container, which we will be using a rubber balloon to hold into it. Now that we have acquired our nitrous oxide, we will need one more material, and that will be a large graduated cylinder as shown from previous videos found on YouTube. To start, we would want to take our nitrous oxide from our balloon and fill up the graduated cylinder with that gas. Now, we don't need to worry about it being displaced by air since nitrous oxide has a greater density than air, so all we will need to do is cover it with just a piece of paper or cardboard just to ensure that nothing really does float out. After that step, we would add a few milliliters of carbon disulfide to the nitrous oxide, and this is going to start creating a mixture of carbon disulfide and nitrous oxide within this container. Carbon disulfide is added to nitrous oxide to produce carbon dioxide, sulfur, and elemental nitrogen. Now we want to wait for it to be fully evaporated, so we're going to let this sit for a few minutes. Shaking it and adding water can help the whole process speed up when it comes to the evaporating process. And then once it is set and settled and we have a good mixture, we can go ahead and light a wooden splint and light it at the very top of the graduated cylinder, and that would be the experiment of the barking dog.